Hello and welcome back. This is Bijan Usha. The focus of this lesson is networking media, devices, and services. We are going to take a look at layer 1 devices such as hub, repeaters, and media, layer 2 devices such as switch, layer 3 devices such as router. We are also going to discuss some of the networking services such as DHCP. Hope you enjoy it. Thank you very much.
Networking media and devices operate based on the specification of the OSI layer they belong to. For example, end devices, such as computers, operate based on application layer specifications. Routers and layer 3 switches are functioning based on the specifications of network layer. They are considered layer 3 devices. Network interface controller cards and switches are layer 2 devices. They function based on the specifications of data link layer. All types of cables, in general media, hubs, and repeaters, are considered to be layer 1 devices. They function based on the specifications of physical layer of OSI. Ethernet is a shared environment. Therefore, collision domains exist in an Ethernet network. Collision domains are going to be eliminated if all devices in that segment are configured to function at full duplex. Most IPv4 services are broadcast based. Therefore, broadcast domains exist in an Ethernet network. Each broadcast domain requires a unique network address. Layer 1 devices are going to forward collisions and broadcast. They are creating one large collision domain and one large broadcast domain. Layer 2 devices are going to filter collisions, but they forward broadcast. They are creating a large broadcast domain, but they are going to segment a large collision domain into smaller ones. Layer 3 devices, such as routers, are going to filter both collisions and broadcasts. Routers do not forward collisions, they do not forward broadcasts. Twisted pair cable is a layer 1 device. Twisted pair can be configured as a straight-through, crossover, and rollover. A straight-through cable is being used to connect devices that are not similar if MDIX is not configured. Crossover is being used to connect devices that are similar if MDIX is not configured. Rollover is a Cisco proprietary to connect a terminal computer to the console port of the switch or a router in order to configure those devices. A serial cable is used to connect serial interfaces of two routers to each other in a point-to-point physical topology. One end of the cable must be configured with clock rate to act as DCE. Wireless devices do not need any cable to connect to each other. However, other components such as wireless NIC, access point, and wireless routers are required. Bandwidth is capacity of medium to carry data. A combination of factors determine the practical bandwidth of a network. They are properties of physical media, technologies chosen for signaling and detecting network signals. Throughput is measure of transfer of bits across media over a given period. This is the actual rate of transfer, as opposed to bandwidth being the theoretical rate of data transfer. Therefore, throughput is lower than bandwidth. Factors that influence throughput are amount of traffic, types of traffic, and latency. Goodput is measure of usable data transferred over a given period. Goodput is throughput minus traffic overhead. Latency is the time, including delays, calculated to travel from one point to another. Hubs and repeaters are layer 1 devices. Repeater is a two-port layer 1 device that repeats, refreshes, or amplifies signals that have lost their strength after traveling on a medium for a long distance. It is rare to use repeater because hubs and switches can perform the function of the repeater. Hub is a multi-port repeater. It is a layer 1 device. Packets arrived on one port of the hub will be forwarded to all other ports by the hub. This creates a large collision domain. Hubs forward both collisions and broadcasts. Hubs ports can only operate in half duplex. As a layer 2 device, a switch will divide collision domain into many smaller ones. Switches forward broadcasts and filter collisions. Switch ports can function at half duplex and full duplex. When they function at full duplex, that segment is collision free. Switch ports support MDIX. As a layer 2 device, each switch has a base MAC address that can be displayed by performing show version command. Additionally, each interface of the switch has a unique MAC address. For example, if you want to display the MAC address of Fast Ethernet 01 of the switch, you can perform show interface Fast Ethernet 01. Switch is a layer 2 device. Switch is built forwarding table based on source device MAC address and the switch port that device is attached to. For example, PC1 is using an NIC. That NIC has a unique MAC address. In this case, we are using 12 hexadecimal digits A to represent the MAC address of PC1. As soon as PC1 starts communicating, it includes its own MAC address in that communication. The switch is going to detect that. It's going to capture that MAC address and associate that with Fast Ethernet 01 in its MAC address table. The same is true for PC2. PC2 has a unique MAC address represented with 12 hexadecimal digits, in this case B. As soon as PC2 starts communicating, switch is going to capture that MAC address and associate it with FA02 in its MAC address table, and that way it is populating its MAC address table. Switches make forwarding decisions based on the destination MAC address included in the frame that they receive and the port that MAC address is associated with in the MAC address table of the switch. In here, switch has learned MAC addresses of PC1 and PC2 and have associated them with Fast Ethernet 01 and Fast Ethernet 02 respectively in its MAC address table. If PC1 wants to send a unicast communication to PC2, it is going to include MAC address of PC2 as the destination MAC address in its frame. That frame gets to the switch. Switch is going to take a look at that destination MAC address. It's going to go to its forwarding table or the MAC address table and find the port that MAC address is associated with, in this case FA02, and it is going to only forward it from that port towards PC2 and not to any other device. Switch forwarding methods include store and forward and cut through. Cut through could be either fast forwarding or fragment free. Store and forward is safest and the slowest method. Error checking before forwarding occurs and forwarding starts after the entire frame has received. Fast forwarding is the fastest forwarding method. Forwarding starts after destination address of the frame is read. Fragment free is the second fastest way. Forwarding starts after the first 64 bytes of the frame is read. By default, all ports of a switch are placed in VLAN 1. They cannot be configured with any IP addresses. However, VLAN 1 itself can be configured with an IP address, and the switch itself can be configured with default gateway's IP address for remote access to that switch after initial local configuration is done on that switch. Other VLANs can be created and switch ports can be moved from VLAN 1 to the newly created VLANs. Each VLAN is a broadcast domain and requires a unique IP network address. A layer 3 switch functions the same as layer 2 switch. Additionally, it can perform some of the router's functions. Therefore, it is possible to configure a layer 3 switches, the ports of a layer 3 switch with IP addresses. Both layer 2 and layer 3 switches have software components such as operating system and configuration file. Their operating system is referred to as Internetworking Operating System, for short iOS. Routers are layer 3 devices. They are intermediary devices that interconnect networks. Routers route traffic from one network to another. Routers have both physical and logical components. Routers' main functions are path determination, packet forwarding. Routers use routes or instructions in the routing tables to determine the best path to a destination network for a packet that they have received and to select an exit interface on themselves towards that destination network. Routers have motherboard, power supply, RAM, ROM, NVRAM, flash, and interfaces or bays for interfaces. Those are considered as physical components of a router. Software components of the router include Internetworking Operating System and configuration files such as routing table, running config, and startup config. Routers have different types of memory. They are ROM, flash, RAM, and NVRAM. Power on self-test and ROM-mon are placed in ROM. ROM-mon is a watered-down version of the operating system for troubleshooting of the router. iOS is the operating system of the router that is located in flash memory. During the boot, iOS is going to be loaded into the RAM. Running config, which holds on to the configuration that you make to the router, is also a file in the RAM. If you want to maintain those configurations during the power recycle or reboot, you have to copy them to a startup config. A startup config is a file that is located in NVRAM. However, during the boot, it is going to be loaded into the RAM of the router as well. In order to access command line interface of a router for configuring that router, which is required as an initial configuration, you need to connect a terminal PC to the console port of the router using rollover cable. And that rollover cable on the other end will be connected to the COM port of the PC. You also need an emulation software such as PuTTY in order to access the command line interface of that router. After connecting a terminal to the console port of a router using a rollover cable and a PuTTY, you'll access the command line interface of that router. The first mode that you'll see is the user mode. The prompt for user mode is router greater than sign. You cannot do much in here. You have to go to other modes. First, you can go to privilege mode. Privilege mode has a prompt. That prompt is router #. In order to go to privilege mode from the user mode, you have to type enable and press enter. Then you'll access the privilege mode. In privilege mode, you can do few commands. They are show commands, copy command, and reload. Nothing else. If you need to configure your router, you have to go to global configuration mode. In order to go to global configuration mode from the privilege mode, you have to type configure terminal, press enter. Configure terminal is not one word. There is a space between configure and terminal. When you access the global configuration mode, the prompt is router open parenthesis config close parenthesis #. If you want to go back to previous mode from any mode, you can type exit. If you want to jump back to privilege mode from any upper mode, such as global configuration mode or interface mode or router mode, you can type end. That's how you navigate between different modes of the router. There are different types of communication. They are simplex, half duplex, and full duplex. Simplex is one-way communication, send or receive. For example, if you press any key on your keyboard, that is an example of a simplex communication. Half duplex is a two-way communication, but one way at a time. You can send and receive, but not at the same time. Example of that is walkie-talkie. Layer 1 devices such as hub operate in half duplex only. Full duplex is two-way communication at the same time. Telephone is an example of that. Ports of layer 2 and layer 3 devices can be configured to operate in full duplex and therefore eliminate collision domain on those segments. Cisco routers and switches support MDIX. Without MDIX, you must use crossover to connect similar devices, such as two switches. However, with MDIX, you can use either crossover or a straight through to connect them. Without MDIX, you must use a straight through to connect a switch to, let's say, fast Ethernet port of a router. But when MDIX is used, you can use either crossover or a straight through. Without MDIX, you must use a straight through to connect a PC to the switch port. However, with MDIX, either crossover or a straight through can be used. DHCP version 4 is used to automate IPv4 addressing. DHCP v4 is broadcast based. Client and server communicate based on following messages. As soon as the DHCP client comes up, it's going to broadcast a message called DHCP Discover. In that DHCP Discover message, the client includes its own MAC address. A DHCP server that receives that broadcast is going to send a unicast message to that client, and it is going to offer an IP address, a subnet mask, and possible other parameters that you have configured your DHCP server to lease to that client. Upon receiving that DHCP offer, the client is going to broadcast DHCP request, sort of accepting the offer made by DHCP server. Then DHCP server is going to send a unicast message back to the client called DHCP ACK acknowledging the lease, and the client is going to be able to start using that IPv4 address from there on. For DHCP version 6, we have different types of configuration. One of them is called stateless address auto configuration, SLAC. The other one is SLAC with DHCP version 6, and the last one is stateful. Under SLAC, the router, through its router advertisement or a message, will send prefix, prefix length, and default gateway to the client. Client will come up with the interface ID using either EUI or a random number. Under SLAC with DHCP version 6, the client will receive a prefix, prefix length at default gateway from the router, the same as the SLAC. However, if it needs additional parameters such as DNS IP address, it has to get it from a DHCP version 6 server. Under stateful, all the parameters are going to be given to the client by the DHCP version 6 server. In SLAC and SLAC with DHCP version 6, devices have to come up with their own interface ID. They can use either a random number or EUI-64 interface ID. EUI-64 interface ID can be obtained from the MAC address of that device. MAC addresses are 48-bit binary numbers. In order to make them a 64-bit binary number, we need to insert FFFE in hexadecimal in the middle of that MAC address, and then we'll have a 64-bit number. The last step of the process is to invert the 7th bit. If it is 1, make it a binary 0. If it is a binary 0, make it a binary 1. Then you have your 64-bit EUI-64 interface ID.
Thank you for watching. If you liked the video and you found it informative, please don't forget to recommend it to others who may be interested. Thank you.